Okay, in this video I want to talk about how to solve an exponential equation where we have the same base on both sides. So the left side is an exponential equation with base 5. The right side is also an exponential equation with base 5. So if we have the same base, then we can use a logarithm to get rid of that base, because we had a rule that said a log of an exponential should cancel each other out. So if this is base 5 and this is base 5, why don't I use a log base 5 on both sides? So bear with me. I'm going to just kind of do the problem and then we'll come back and talk about it. Okay, so I've used a log on both sides. It turns out that's a thing that you're allowed to do, like adding a number to both sides or multiplying both sides by 2 or taking a square root of both sides. We're allowed to take a log of both sides. And then the rule says log of an exponential should essentially cancel each other out, and the same thing happens on both sides. And I said at the beginning of the video that we're looking at exponential equations with the same base. If this had been like a log base 5 and this number had been like 12, then those two wouldn't cancel. We only cancel if we have a log and an exponential that happen to have the same base. So in this case, log base 5 and exponential base 5 cancel each other out. And that's the reason why I used a log base 5 on both sides, so that the exponentials with base 5 would end up canceling. And so what we're left with is just x plus 2 on the left and just 9 minus x on the right. And so I mentioned in the last video, you still have to solve whatever equation you end up with. So we're not done. We've just made it much simpler. We don't have exponentials anymore. We just have x's and numbers. So let's see. I want to move my x's to one side, so I will add x to both sides. And I want to move my numbers to the other side, so I will subtract 2 from both sides. So 9 minus 2 would be a 7. The x's go away. Let's see, the 2's go away, and x plus x is 2x. So 2 times x, to undo multiplication, we use its opposite or its inverse, which would be dividing by 2. So we get x is equal to 7 halves. And if you wanted to, you could check your answer by plugging this number in for the x. Okay, something to be really careful of here. If we have the same base on both sides, we need to be using an exponent. I can't like take a root of both sides, because what root would I take? Would I take an x plus 2 root? What the heck does that even mean? So just be careful. If you see an exponential equation that's different from a polynomial equation, if the x is in the variable, we need to use logs to get rid of exponents. Okay, let's try another one. So let's try and solve 4 to the power x is equal to 2 to the power 7 minus 3x. Okay, at this point you might be feeling a little cheated, because the whole topic, the header of the video was exponential equations with the same base, but see, obviously they have different bases. Turns out that's not a big deal, because they're both still powers of 2. And so maybe I can use rules of exponents to rewrite both sides as the power of 2. In particular, I'm going to rewrite 4 as 2 squared to the power x. And now this is starting to look like we have exponentials with base 2 on both sides. And remember, our rule says if you have a power of a power, then you multiply the exponents. So the left-hand side is 2 to the power 2 times x. And the right-hand side, I haven't changed at all. Okay, now I can do what I did in the previous video, or sorry, in the previous example, and take a log of both sides. And since I see a base of 2, it makes sense to use a log base 2 on both sides. So if I use a log base 2 on the left-hand side and a log base 2 on the right-hand side, then the log and exponential should essentially cancel each other out. And again, this is happening on both sides. And so what we're left with is the 2x and the 7 minus 3x. Okay, and then just solve normally. So this is now a linear equation. We want to just move numbers around. So I will add 3x to both sides to move all my x's to the left. That gives us 5x on the left and 7 on the right. Divide both sides by 5, and we get x is equal to 7/5.